Good everyone, my name is Graphics. If you look at the front of your screen, you will see a question, and the question says the probability that machine A will be performing an unusual function in 6 years' time is 1 over 8, while the probability that machine B will still be operating usefully at the end of the same period is 1 over 6. Find the probability that Roman figure 1 both machine will still be performing an usual function. Roman figure 2 neither will be operating. Roman figure 3 only machine B will be operating. Roman figure 4 at least one of the machine will be operating. Now, to make work easier for you is for you to write out all the givens. So the givens here, the first thing from the statement, from the sentence we have, or from the question, it says that machine A will be performing an usual function in 6 years, meaning that machine A will be working. So the probability that machine A will be working, right, in 6 years' time is 1 over 8. So I'm going to write it this way: probability that A will be working, or A is working in a bracket, or A is performing a usual function, depending on how you want to write your English there. Altogether is given as what? 1 over 8. Having in mind, we are saying probability, that means is a game of what? Is a 50-50 chance that this is true. Altogether. So automatically there will be a time that the machine is not going to work. So how can we get that time? What we'll do is you now write that probability that machine A will not work, or I can say probability that machine A will not be performing an usual function, or I can say machine A will not be what? Active in this period. So for me to write it will now be 1 minus what? When machine A is active. And when is machine A active is 1 over 8. That is the value there. So that is for that bar. The next one, it now said while another machine B will still be operating usefully, at the end of the same period. So that means operating means it's still working. So you now write the probability that machine B is active, or you can say probability that machine B is working, or you can say machine B is operating usefully. And what is the value given is 1 all over 6. So automatically there will be when machine B will not be active, or when machine B will not be operating usefully. That will be 1 minus when machine B will be operating usefully. And that is what? 1 minus 1 over 6. So if you look at both of them, we subtract 1 minus 1 over 8, we'll be having 7 over 8, right? And if you subtract 1 minus 1 over 6, you'll be having 5 all over 6. Is that taken? So this is what we have here. So we're now told to find probability that for the first question here, question Roman figure 1, both machine will be performing an usual function. So it means that machine A will be performing usual function and machine B will be performing usual function. So this means that what? Probability of what? A intersection what? B. Because A is representing machine A and B is representing what? Machine B. So it will be probability that what? A intersection B. And probability of A intersection B means that what? Probability of A multiplied by what? Probability of what? Of B. And that is given from our question. Probability of A, that is A means machine A is working, is what? 1 over 8, and machine B is working is what? 1 all over 6. And when you do the needful here, we'll be having 1 over 48. Is that taken? So that is for the first one that we have here. For Roman figure 2 here, it says neither will be operating, right? Neither will what? Will be operating. So when they say neither will be operating, it will be machine A will not work and machine B will not work. And that is what probability of A complement intersection B complement. So probability of A complement is given as what from our question here that we'll solve. That is when it will not work. Let me write it down there. Is given to be 7/8, right? And when B will not work, will be what? 5/6. So if you multiply both together, we'll be having 35/48. That is when neither of them is working. Remember, probability of A complement intersection B complement means probability of A complement multiplied by probability of what? B complement. That is for that particular one here. So we're done with that. Now the next one, that is Roman figure 3. It says only machine B will be working. Now, only machine B will be working means that what? Only B is working and A is not working. Right? So it means that A complement intersection B. Probability of A complement intersection B. So it means that when it says only what? Only machine B is working. So it will be probability of machine B is working and probability of machine A is not working. That is what they mean here. So that's what that statement means. If only B is working, it means that A will not work. So it's just saying that B intersection A complement. Are we good? So when you put the needful, what is when only B is working? When only B is working here, it's given to be 1/6. Right? If you do the needful, only when B is working is 1/6. And when A will not work is what? 7/8. That is 1 minus 1 all over what? All over 8. So it will give me 7/8. So if I do the needful, it will be 1/6 multiplied by 7/8. And that is 7 all over what? 48. Is that okay? So that is for that other one here. So the last but not the least, Roman figure 4. At least one of the machine will be working. There are many ways you can go about this last one, but what you do here is if one of the machine is working, at least one of the machine is working, it will be that 1 minus when none of the machine is working. That is when machine A is not working and when machine B is not working. And that is under neither. And we calculated it for here. At this point, we calculated it. And when it is neither here, it's given as what? 35/48. So it will be 1 minus 35 all over 48. Or I can easily say 1 minus when machine A is not working, which is 1 minus 1/8, and machine B is not working. So with what we have here, this is how we'll come about it. So when you do the needful, you'll be having 1 minus 35/48, and that will give us, if you do the needful here, it will be 13 all over 48. So that will be our answer. So if you have found this helpful, don't forget to like, subscribe, and also share the video. Thanks for watching.